Right. Let's see here. Just make sure that we're recording. No, that's not what I want to see. All right, cool. Okay. Again, let me just make sure that this is recording. All right. All right. Good morning, good afternoon, good evening. Thanks for tuning in again. It's another wonderful day today. It's Wednesday, which means it's closer to Friday. So that's great. It's sunny out. At least it is here. Beer of the day today. No, not. I should start having like a beer of the day pick. This past weekend, I had this one. What's it called? Ransack the Universe. I think it's an IPA. So I don't have a can of this, but and it's really cool. It's this. I think it's a brewery, Collective Arts Brewing, and what they'll do is they will sort of get designs, I guess, from 500px, and they will put the pictures or the illustrations, if you will, and they'll post them on the cans, and they always have like really cool designs. So yeah, and the beer wasn't bad. It's got a 91, which is outstanding. So the beer was pretty good, but the can design was awesome, which I think that's part of the reason why I picked it because it can look cool. Um, but stamina, in terms of stamina, we are sort of in the final leg of this thing, and I was taking a look at the what was I looking at? Um, I was taking a look at the data set, right? So Microsoft Kaggle malware classification challenge. So I was taking a look at this thing here, and I found something that was a little bit unfortunate, which is that there is no way for us to test and to see how well we did. Okay, do I have to be signed into Kaggle to see this? So there's no way for us to see how our model is performing. So the model actually trains. So let me actually pull that up first to kind of show you what happened here. Bum, 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 bum. Oh, and actually, before I even go further than that, um, mm, 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 baseball decision analysis .NET Blazor. Let's see if it's indexed. So there's this really cool project um, put together by Bart here, who um, who put together this really neat project that does decision analysis, and it uses ML.NET alongside several other services. Like it's built inside of a Blazor application, and it's really cool. So he provides this architecture, right? So if you wanted to go ahead and implement your uh, if you wanted to go up and implement this particular solution, right, he sort of provides you with the architecture and the different systems and how they interact and stuff like that. Um, Also, if you are interested in learning more about this, it was, let me see, Microsoft Docs. is it? Is this it? No. Let's see. I know it's on my in my Twitter. That's for sure. I tweeted about it. I wish I would have had the link to show you guys. Yep, there it is. Wait, are you kidding me? Did I not? Oh, man. All right. So my fault. I thought I had provided the link to this. I guess not. I will have to retweet then because the intent was for the link to actually be there. Let me see if Mm-mm-mm. Let's see here. Let me actually open an issue here. Actually, not. Baseball decision analysis, ML.net. There we go. So this is what I was trying to refer to. And it's pretty much the same thing, except that it gives you a little bit more detail. It's a little bit more, uh, talks about what the relevant use cases for these types of applications are. It also shows you the live version of the solution, right, which is kind of what we saw here earlier. And you can either look at, using a rules engine, right, which in this case, it's not really using machine learning from what I understand. And in this case, with the what if scenario, the other what if scenarios, these are actually using models, right? Or machine learning models built with ML.net. So it's a really cool project. You should certainly take a look at it when you have time. And I will actually tweet the actual link because I didn't. Okay, cool. So going back to stamina, uh, there's no way for us to really evaluate our model. So if I go here to, let me try to open up the connection to the VM, right? All right, so that's the VM. If we check out tmux, oh, um, crap. How do you? Let's see. Tmux close session. Close the tmux session. Let's see. Close on command examples. Nope, I don't want to install it. I want to tmux new. Let's see, detaching. Nope. Nope. Let's see. Kill. Let's see. Current tmux session. Okay. I just want to do this one session. It's been a while since I've done tmux. So other than attach and detach, I'm kind of rusty here. Nope. Rename list. Jumping. Load. Kill your current. Okay, so is it really that easy? Control B. Killed session. Tmux ls. Okay. So now that we have this tmux ls tmux a-t to attach the train model. Okay, so here's the model that trained, the one that we left training last Monday, and It actually didn't take that long. It literally took an hour to complete. And what we can see here is that um, the training, let's see. So the training accuracy was 89%, and the validation accuracy was 88%, which is pretty good. It's pretty decent considering we did nothing. Well, number one, I don't know if we did the pre-processing correctly of the images. I'm gonna assume that we did pretty good. Um, so 88% of accuracy. It's pretty good. It's decent. Again, considering that we didn't do too much to the data, we didn't augment it. We didn't really do much with it. Uh, and the other thing that's pretty good is also is, well, actually that part isn't good, which is the accuracy. We would hope that the accuracy is a little bit higher on the validation than it is on the training. So that may be a problem at some point. Now, what we would want to do eventually is we'd like to use our test images to take a look at how our model is performing. Now, unfortunately, we don't have any test labels. So if I were to pull, let me see, window, and let me see, Kaggle, malware classification, right? So if we go here to the malware classification, and we were to look at, oh, I'm not signed in. All right, no worries. I'll just sign in here. Email. I think. Okay. I think I forgot my password. Let me see here. So this is already not getting off to a good start. You know, it's been like this for the past few streams. This last time my stream crashed, and this time it seems like it doesn't want me to log in and evaluate it. Um, but essentially, if I can only show you, let me see here. Kaggle.com, malware classification, sign in with your email. Sorry, just bear with me. In the meantime, while this is happening, let me actually open up Visual Studio Code so that way we could at least start logging into our VM and get our resources set up there. Okay, so there's that. SSH targets. So in the meantime, to kind of also buy some time, how are you folks doing? Are there any projects that you're working on at the moment, or streams you're watching that are doing interesting projects? Oh, another thing I saw that which is really exciting. Let's see here. .NET Conf 2020. I think the dates have been set. Let me see. Yep, there you go. So .NET Conf 2020 is official. the date is in the books, right? So that's going to be November 10th through the 12th, and I think the yep, there you go. So the CFP, or the call for content, that's going to take place in July. So if you have any interesting projects, if you have anything that you would like to talk about, by all means, submit it. The previous .NET Comps, they've been really cool. It's really nice that there's been these smaller conferences, sort of like a focus. So after .NET Conf, what started happening was you to have these conferences that were specifically um, sort of focused on a specific technology. So, like for example, I think that one of them was on Blazor, right? I think that the very first one was on Blazor. I think there was another one on microservices. So, um, yeah, so there's always tons of really cool content around .NET. So again, if you have any topics or anything interesting that you might want to share, right? I would highly encourage you to submit your um, you know talk or presentation. I have no idea what's going on here. All right, so while that's going, let me go back to this thing here. Okay, so there's this. Okay, let's see. Let's actually open this folder. Okay, so I hadn't forgotten my password. I think maybe what's my username? Let's see my profile. Oh, that's my username. Okay, makes sense. I was putting in the wrong username. Yeah, John, I would certainly encourage you to submit. I know you have tons of really great content. Um, so yeah, I mean in the past, it's been a mix, right? So I think the first, let me see how many days this is. Um, no, not Tmux. Let me actually just click on the link that I pasted in the chat, because that might make it easier. There you go. So in the past, what you would happen, it's, let's see, 10th through the 12th. Day 1, 2, 3. Yep, there you go. So day 1 typically is focused around like they tend to be mostly internal sort of presenters, right? Like so internal to Microsoft. And then day 2, I think it's a little bit of a mix between community and Microsoft. And then day 3, and by community I mean it really is, everybody's part of the community, right? Including Microsoft when it comes to .NET. Um, but I mean like sort of like individuals that are non-Microsoft. Um, they tend to sort of do their presentations day 2 and day 3 as well. So yeah, I mean there's tons of opportunities to submit to this conference and really just show off all the cool projects that you've been working on. In the meantime, let's see here. Okay. All right. So is this the right data set? Yes. Okay. So if you take a look at this here, there is no way for us to test it. So the sample submission is a way for us to kind of like what it sounds like, submit, right? And what it will do is we have to, what I'm guessing here is we have to provide the probability for each of the classes, right? And once we submit that, there's going to be some sort of system on the back end that's going to kick off, and it's going to try to submit our application for us, or try to evaluate how well our model performs. If we take a look here at the leaderboard, it will show you. So the score, it's a multi-class loss. That's kind of what they're using to evaluate. It looks like the top team members here, the top team here, achieved a 0.0283, which because we're looking at a loss here, um, you want to minimize that. So lower the better. Um, and they did a pretty good job here. So let's see here. So that's kind of what I'm gonna try to do. I'm gonna try to submit it and see if we can still get this back end system to work. We won't be able to get the $16,000, but at least we'll be able to evaluate. And this is unfortunate, right? Because I would much rather prefer that we were able to evaluate it locally, but it seems like that won't be that won't be the case. Let's see. Privately sharing code or data outside of teams is not permitted. So share code is made available to all participants in the forums. Okay. Open licensing of winners. Winning solutions need to popular OSI. Winning soon must be posted or linked in the forums. Yep, we're not gonna win. So, teammate mergers, team limits, submission limits, 5 entries per day. Let's see. Winners, competition specific, eligibility, submissions. Okay, submissions mean material submitted by you. Form, okay, may submit up to maximum number. Submissions must be received prior to the competition deadline and adhere to. Okay, that's fine. May not use from hand labeling or human prediction. Okay, is a multi-stage competition. Okay, intellectual property. Code sharing. Participants are preferring privately sharing source in connection with disqualification. I don't get what this means. Participants are permitted to publicly share source and executable code developed in connection with data or otherwise not provided such does not intellectual property rights of any third party. Yep, that's fine. We've done that. Winning. We're not going to win. Well, I'm not saying we're not going to win, but we definitely can't win the prize anymore. Let's see. Obligations, delivery, and documentation. Yep, we're not in it to win it. Teams, warranties, and obligations. Okay. I mean, I'm just trying to make sure that we're kind of abiding by whatever this thing says, right? That we're not. What's this here? Late submission. Oh, I can just upload it. Cool. All right. So let's see here. My submissions. Leaderboard. Okay. So let's go back to the project and let's try to score. So we got to the point where, what's going on here? Let me just try this again. So we got to the point where we trained our model. So now it's time to evaluate it. Now to evaluate it, we had a test data set, and I think we had about 10,000 images as part of that data set. So that's what we're going to be doing now. We're going to be using, we're going to be doing a few things here, as long as we can get this working. So considering that we're getting towards the end of this, some of the things that I want to do, going forward, there's this other project that I want to play around with. It's related to this, but I want to use AutoML to do that project, and it still uses Kaggle data. So we're going to be working on that. But after that, I kind of want to get back to doing the workshops, right? The Reactor workshops, and kind of going through those and trying to build out the code and doing things in .NET. So that's, I think, for the time being, kind of what we're going to do. Let's see here. Training console app. Yep, it's this one. And as you can see, there's my mlmodel.zip, which is what we saved last time. So, okay, so save the model. What I want to do now is I want to use the model to score, right? So in this case, what I'm going to do is I'm going to look at load, what is it? Let's add some comments here that way. So load training data into our data view, create pre-processing, create training pipeline. define algorithm trainer. In this case here, I want to define post processing step. Combine pre-processing trainer plus post processing pipelines, and then finally here train the model, right? Here save the model. Okay. Load test data. All right, and we're gonna do pretty much the same thing that we did here to load the test data. Right, so this one's gonna be load image test data. This one's a little bit different because in this one, yeah, in this one it's a little bit different. In this one, like we don't have a file that we're looking at. In this case, we are literally just loading we're literally just loading. So if we do data drive / what? Test images. Right, it's all just images. And there is no way for us to get the sort of like train data drive. Okay, so there's no way for us to get this nice thing here like this, right? Like the name of the file along with the class. So we're gonna have to write another function here to load only the files. So get image data. Let's see, let get image data from files. And then this one's gonna be the data dir. Actually, do we even need this? We don't even need a function. I think we can just do it all in here. So forget this thing. And what we're gonna do is we're just gonna do file dot directory dot get files, and then we're gonna do where we're gonna get files from data drive / it's data drive test images. Yep. Let's actually test this out in our script here before trying it out. So let image test data is equal to directory dot get files. I want to get it from data drive test images. Okay, so when I look in this directory, I want to get the files. Or get the file paths, that is. Oh, of course it's not going to work because I need to system.io, and when I do this, there we go. Okay, so that's that. And then what I need to do is I need to array.map fun file path is equal to nope. It's gonna be what is it? Image path. So image path is equal to file path, and label is equal to this, right? And the reason why we're doing this is because we're using records, and when you're using records, you have to basically set a value for each of the properties, right? So in this case, because we're doing test data, we don't care about the label because that's what we're trying to predict. So that's number one. And number two, we don't have a label, right? So it can be whatever in this case. So let's see. How does, whoa. Oh, yep, it's not gonna work because I need to, this, boom, awesome. Okay, perfect. This is what I need. And the last thing that we need to do is we need to provide a way to get to access the values in our to access the prediction values, right? So we need to define another record that provides our schema. But let me see, image classification. I think that the two default columns for accessing this data are predicted label and score, which gives you the probabilities of the classes. But let me just make sure. ML.net. So image classification trainer. Okay. So, yep, there it is. So score, which is a vector of single, and again, it scores all the classes. Higher value means higher probability to fall. The predicted labels would be I. So the I is zero indexed. The predicted labels index, predicted label. Yep, or the ith category. Fine. Okay. So we need to create as another type, image prediction. And then we need to give it a predicted label. And this will be a string. Hey, how's it going? Thanks for joining. So there's a predicted label. Oh, there's gonna, right, but there's gonna be a key type. It's gonna be a string. Yeah. And then the score will be float 32. Or can I do single array? Not gonna work? No. Single. Yeah, there we go. Yeah, let's go with this for now. And we got to remember to make it CLI mutable. Mutable. Okay. All right. So let's take this and let's put it back in our program. And then let's take this here and actually add, we're going to add another step. And this is kind of what I love about piping. I guess we can just do this, right? Just do this. And then here, what we can do is we can say CTX. Is that what I call it? No. What do I call my ML context? CTX. Yeah. CTX dot data dot load from enumerable. Boom. There you go. So we look, get our file paths. We create an image data item. We pass it into loads from enumerable. Oh, I might even do this. What is it? CTX dot, no. It's gonna be model dot fit. Can I do that? Oh, sorry, not model dot fit. Model dot transform. Oh, look at that. Look at how nice that is. Okay, so this is one of the reasons why I like it. So what we did here was we called this, right, a directory of files, which is going to return an array of file paths. Then what we did was we created a function, and what we did is we mapped that and created image data type enumerable or array, right? So we converted that. We then piped that through to this function, called load from enumerable, where we converted the IEnumerable into an iData view, and then we pipe that as input into our model.transform. And that, I think, looks very, very nice. So now it's not even image test data, image test predictions. Boom. There you go. Thank you. I appreciate your approval of my type operator. Oh, actually, this is our training application. I wonder if we should create if we should create another application for testing. And part of me says we should. Let's see. Q. All right. So part of me says that we should probably go with a new. So list. Just make sure. Okay, cool. .NET new console predict console bang F sharp. Okay. Do I like that? Yes. All right. So what we want to do now is we want to go to our predict console and we want to do two things. We should probably, this is growing, but eventually what we should do is we should probably have like a common class library where we define our data types here. That way it could be shared between the training console and our predict console application. But for the time being, we're just going to copy and paste because I think that will work. And I don't want to take the time to sort of separate it out. At some point, I do want to clean this project up, though. .NET solution add test or the console. .NET solution list. Okay. All right. So at some point, I want to clean this up, and I want to use documentation. I want to rename some of these files just to make it cleaner, and yeah, just make it better overall. So, but for the time being, we're just trying to get this to work. So let's see here. So training console, there's that, and then what we want to do is we want to test predictions. So maybe this .NET package Microsoft. Okay, so let's install the Microsoft ML package, and here we want to do open .ml, and what we want to do is here we want to initialize our context, right? So let's ctx equals ML context. Okay, and what we want to do, let model is equal to, well, first of all, let me copy this, right? So cp model.zip, train model.zip. Okay, so now we have the model here. So ctx.model.load. And the file path is ml model.zip. So we give it the path of the model, right? And here, out dv schema. Let's see, how do you do by refs in F sharp? I remember I did this before, but I don't remember. Let's see, F sharp by ref. Okay, so by refs. Pointers for reading and writing underlying value. So in ref, by ref. So is it really just by ref data view schema? Rest and manage pointer. The value constructor by ref. Okay. To write a pointer by using an outref, you must also make the value grab pointer to mutable. So you're saying this. No. So by ref. Yeah, so if I want to access it, right, if I want to pass the pointer, I do this. Outref is not defined. Should only be used with F# 4.5. Yeah, but I do have that. Yeah, and having ampersand before the variable and getting before the variable. Oh. I'm saying like this. But then how do I ref returns, ref read only, in outref, outref. By ref, argument input schema doesn't match. Oh, there we go. Cannot take the address of the value returned from the expression. Assign the return value to a let-bound value before taking the address. Okay. So let's X. I don't know, DV schema ref data view schema. Okay. And then this. Complete. Okay. It's equal to default. Indicates an implementation of the abstract method, but used together. Okay. Getting rid of the, yeah, having the ampersand before the variable. So now it stopped complaining here, but now it doesn't like this. Saying here. Because if I just do this, right, so what it tells me is I cannot take the address of the value. Let dv schema ref is equal to and dv schema. Let me see, dv schema ref. Oh, you're saying this, so equal to and dv schema. Schema. By ref data view schema. No. Oh, so you're saying, okay, so let dv schema, or sorry, and dv schema. in the chat. Yeah. Yeah, I'm thinking I might try it in the console as well, because data view schema. Yeah, this isn't working. All right, so let me go back to the documentation and see what it says. By ref returns. Scoping. By ref datetime. So this takes it's a function that has by ref datetime, and then mutable dt. Okay. So here's what we can do. So it's gonna be let mutable, I don't know, dv to default, but then it doesn't like default. Okay, so there's dv. Now where do I get my data view schema? Let's see here. Where do I get my data view schema? So this one, it's not really coming from anywhere. So I should, my data view schema isn't really anywhere. My data view schema is, like, I should be able to pull it out. Where it actually was defined was here, right? It was the data view schema of my training data view, right? Which would essentially be my image data, right? So it's got to have, I mean, the only thing I could think of is DV schema. Consider the following code. Okay, the pointer should only be written to. I wonder if I need to, like, import something. No, it should just be system. So, for example, let x I don't know, string is equal to hello, and then if I were to do something like print fn fnx, yeah. So let me create another Scratch project here. Scratch.fsx, okay, or script, whatever. So if I were to do open system, and then if I were to do let print hello, and then x by ref string, okay, and so to x hello print fn percent s x, okay, boom. Okay, so there's this, and then what I want to do is now I want to say print let mutable y is equal to default. Why can't I set it to default? What if I were to put string here? Why doesn't default work? Isn't it supposed to implementation rejection method used together with, oh, okay. Let's see. That's exactly what I was looking at. Like I'm gonna guess that it, let's see, what is the equivalent of sharp of the C sharp default? So it seems like default int. It was limited to the most common default T generic extra has no constraint library function. You know what I need for default off using the option type. And nope, I know what I want. Okay, so could I do, let's see. So if I were to do here, right, let mutable y is equal to default string. Does this work? No. Oh, this is C# code. In here, you tell it ref string. There you go. Okay, so this is how you do it. And then here, I just do and y. I think? Why didn't this work? Okay, so it didn't work, but I think it might work here. String console program.fs. All right, so let's try this again. So let dv schema is equal to ref data view schema. Do I have to make it mutable? The type has no accessible constructors. Okay, we're right back to where we started. What's this? The input schema doesn't match. Stream. Wow, I was not expecting this piece to take as long. It should have been easy. Let's see. Okay, so see if we can find something. F sharp. I think it's the same one. Parameters and arguments. No, it's not optional. Okay, C# has an operator. Unchecked dot. F sharp has a similar construct as a library function. Unchecked dot default off. Okay. Can we do that? Uh, can we do that here? Unchecked dot default of, and then what was it? Data view schema. All right, that worked, I think. I don't know what effect it's gonna have on my code and if it's gonna screw it up, but the compiler seems to like it. I want to investigate this a little bit more, though. What is unchecked dot default of? Generate a default value of any type. This is null for reference types. For structs, yeah, see, I don't like this because now we get into the null. Okay, this function is unsafe in the sense that some F-sharp values do not have proper null values. Yeah, see. I don't like this, but let's go with it for now. Here we can do this open system.io. Okay. And then test predictions. But then the other thing that I want to do here is, now that we have the transform, I want to turn this back into a an enumerable. Data dot to dot load from enumerable, create show me again where you initialize DV schema. Yeah, so the way oh, we went through this whole thing. Yeah, sorry. Okay, so here's the thing. My mind was lapsing right now. Okay, so in ML.NET, when you're saving your model, right? So here's my model, right? When you're saving your model, let me minimize this. Can I? No. There we go. Okay. So when you're saving your model, right, you're able to. It is shadowed. No, it's not shadowed, or at least, yeah, I don't think it is. It's an out parameter. Exactly. Yeah. So when we train our model, right, one of the options that we can provide when we're saving our model is the schema of the data that we used to that this model takes in as input, right? So if we take a look at this, right? So one of the parameters is the input schema, right? And this may be useful if, like, you want to get information like, hey, which columns, let's say you have data, right? And you don't necessarily know which columns you might want to use or which ones you might need. For your model, this might give you information about, like, what's the schema that this model is expecting, right? So when you save your model, in addition to saving, the algorithms and all the information about it, and serializing the information about, you know, your coefficients, if you will, right? Your weights, whatever you want to call it. You can also serialize the schema of what inputs this model is expecting, right? And then on the load side of things, you're able to get this schema, right? And if you want, you can use it and stuff like that. Now, if you're not going to use it though, you could literally, and I completely forgot about this. What you could do is let model is equal to ctx.model.load ml model.zip. We can do this. Oh, can we? We can't? Indicates absence of objection. Also, generic input schema. Interesting. I thought we could do this. I guess not. Does this work? No. All right, so I guess we can't do this. But I think in C# you can. We'll have to try this out later in C#. But anyway, long story short, if you're not going to use it, right, like it doesn't matter if it's here and you declare it and stuff like that. But yeah, it's an out parameter, and you're able to then again take that and basically, do stuff with it. But in this case, we don't really care for it because we're not really going to be using it. All we care about is loading our model. So now that we've used the model to make predictions, what we want to do now is we want to, what do I want to do? It's data dot create. I forget the API call. Let me see. Inspect intermediate data ml.net. Forgot what the. Let's see. Inspect data view values one row at a time. No. Assessing specific data that create enumerable. Yeah, that's what I thought. Data dot create. There you go. Create enumerable. And I want this enumerable to be of type image prediction. Oh, crap. Okay, fine. I can't do this. Let's see. Fun, IDV. This is gonna be the no. That's gonna be the first value. Dot data dot create enumerable ID false. All right, I guess I can't do that. Let's see. Prediction enumerable is equal to ctx dot data dot create enumerable. And what we're going to be doing here is we are going to create an enumerable that takes in our test predictions, and we set this one to false. It's not going to work because we need to. There we go. So the other thing that we needed to set was like reuse row object, and what this will do is, if you're iterating it, like if you do like a for loop or something like that, it's just going to allocate memory to the specific row that you're going through, as opposed to basically, instantiating the entire. Oh, sorry, it should be true actually. It should be true because we're going to iterate over this. So as you're iterating through this, it doesn't instantiate the whole list. It only does it one row at a time, kind of like a cursor, right? Okay, so what we want to do is prediction dot enumerable dot take 3 print seg.map. Is it a sequence? Yeah, you can iter print fn percent a. Okay. So let's print out the first 5, right? So, okay. So let's try this out. So what we did here was we initialized our ML context, right, which is going to be our entry point. Then we loaded train model. Then we loaded. Um, use the model to make predictions, and then just, I don't know, inspect predictions, right? And we're gonna inspect our predictions, and let's see if this works. So now let's go back here to our bash .NET build. And let's do .NET run. What happened? Exception but strong. Cannot find image analytics. Okay, so do I have to basically install everything that's here? My guess is going to be yes. So let's do this. To be safe, let's take the same packages that we used for our train console, and let's use them here as well. .NET restore. .NET build. And then let's run this. It's taking a while. And here I thought that by now we would already have our submission ready. It's never that easy. Okay. Are we getting any? All right, there we go. .NET run. Okay, fine. That was actually pretty fast. How come it's not printing it out? This should. First dot. So I did do a sequence. I wonder. I wonder if it's this image prediction. Like if because it's like, I wonder if it just doesn't know what it's supposed to do. And if I do sig.iter print fn percent. Oh, right, like this should work. Like this should have printed something out, but instead it defaulted to object. And my guess is the reason for that was because I hadn't specified, hey, what type of object are you supposed to build when you create this enumerable. All right, so now it's getting to work. Okay. Interesting. It's taking a while. Reuse. There you go. Yep, that was it. Okay. Nice. Now. Okay. Perfect. Perfect, 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 perfect. So now, actually, what the one. There's a few things that I want to do here. Get file name. Yeah, so there's a few things I want to do here, right? So if we go back to what what our submission should look like, if I can find it here. So our submission is supposed to look like this. We are going to have a few columns. One, it's going to be ID and prediction 1, 2, 3 through 9, right? Through 9. And then we're supposed to have the ID or the name of the image and the float values, right? So we need to make a few changes here to our script here. So one of the things that I want to add here is going to be the ID string, right? And now this is going to fail because it's going to be like, I don't know. Oh, actually, yeah. Yeah, this is kind of going to screw. It's going to, well, is it? I don't think it is. It is. So ID is equal to, let's see here. Let image name is equal to file path dot split slash actually if I go here, right, so it's going to be this here, open system.io, and what I want here, it's this here, right? So I want to see kind of what this looks like. This, and then what is it, image data? Yeah. Okay. So we're gonna have to change this up a bit. First of all, let's start off here. And then this. Right, so what does this look like? Test predictions. So what I would like though is I would like to add something called ID. And this is going to be string. And what's going to change here is it's going to be let image name is equal to file.get path.get file name that extension, and it's going to be what, file path, right? And then ID will equal to image name. Boom. Now let's see, what does this look like? ID is not defined, and of course it's not because I gotta do this. Perfect, 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 perfect. Okay, but I wonder if this is gonna now screw up my if it's gonna screw up my string, and then this piece here, right? I want to change this a bit. Boom. Okay. So I wonder now if this is going to get screwed up. Let's try it. Because now my schema changed, right? Like the schema that we trained with didn't have this ID, and as a result, it might complain because it's like, hey, you only have image path and label, but now you're giving me this ID. I have no idea what you're talking about. Um, but let's try it. I mean, hey, it doesn't hurt, right? Let's see, output debug, terminal, bash, okay, .NET build, .NET run. Fingers crossed that it doesn't complain. I think we should be fine as long as we have the same columns that were used for the training process. It doesn't matter if we add extra columns. I think we should be okay. Success. Success. Um, maybe. Yes, it is. It is. It is success. Um, almost. Almost. Now, the next step is let's get this into a CSV. So let's see. Um, let's see. How can we make this nice? I want to make it look. All right. So now that we got our prediction enumerable, the next thing is we need to turn this into a CSV. So we know that there's going to be ID. So let header is equal to it's going to be let's see, prediction 1, 2, 3, 4, 5, 6, 7, 8, 9. So all right, I'm not even going to complicate this. I'm just literally going to do a copy and paste. So it's going to be ID. I was trying to make it look nice with like a list.reduce or like a string.join, but you know what? I'm not even going to worry about that right now. I'm just going to, what is it? It's prediction 1. I'm just going to hard code this. I should probably make it look nice, but that's okay. Maybe in another iteration. 3, 4, 5, 6, 7, 8, 9. So 2, 3, 4, 5, 6, 7, 8, 9. Okay. So there's going to be your header. And then our data, right, will be it's going to be the ID plus, so it's going to be if we're to take this prediction dot take I don't know, 3, and then here we just did seg.map string. It's going to be id dot fun I don't know, pred dot score dot join. String dot join comma pred. Okay. Result of this version is type seek way and it's implicitly ignored. Oh, sure. Let's see. Let scores equal to right, so what I'm doing now is I'm making everything into a CSV, or at least all the scores. And then the other thing is that's missing then would be the sample submission. And then I think we might be in business. So once we do that, then we should be able to just submit this and see how well we perform. Okay, so did I run the wrong program? This is not what I was expecting. Oh, dot score. Dot at run. Okay. Now while this is going on, let me go here. File stream fs is equal to file stream, and it's gonna be what? Submission.csv. fs dot write. What is it? fs dot write line. It's gonna be header, right? Okay, it's still going on here. So what I need to do a new file stream. Okay, it's recommended I was just porting out a disposable interface. And now this one's taking a little bit of time here. Take one argument overload file, take two arguments, comma. I forget what file stream takes. Let's consult the docs. File stream. Alright. Let's see, file stream. io.filestream. I could just say file.create, but let's see. Methods. No, I want constructors. Specify file handle, specify read-write permissions, file access dot. Okay. This is taking a little bit of time here. Let's see. File access dot. Can write. Let's see. Can write. How does it call right? Okay. Wow, this is really like. Let me see what's going on here. connect now. Did it crash my server? Okay. There's no way that that should have happened. Should I reload the window? Come on, I was doing something important here. All right. Let's see. Okay, so one CPU was at 100%. But now it mostly seems okay. So let's quit. Let's go back here. It's in the middle of doing something important here. And that's when it decided to crash on me. Okay. All right, I'll let you do your thing. On this side of things, though, file stream. UseFS equals file dot open right, and it's gonna be submission.csv. All right, get rid of you here. fs dot right. Could have sworn that you could. Let's see here. File stream, can read, methods, write, async, asynchronously, sequences, current stream, file dot write line. Okay, this VB though. I want C# or anything else. Let's see, .NET, API, file dot write line, write line. Okay, hold on. Before we do that, let's make sure that this thing works. File stream fs dot right. Yeah, but I don't want to do that. File dot write all lines. Yeah, what I could do is I could do that. Okay, let's see. Let's .NET run. CD test or predict .NET run. Let's make sure that our scores are looking good. sprintf %s comma %s, and it's going to be pred dot D. Oh, yeah. This one's, yeah, that's fine. And then string.join. This one's going to be, you're going to have to invoke yourself like that. Okay, there it is. Perfect. Okay. What's going on here? System arguments. Okay, I guess I had an extra one. .NET run. Let's see how this thing handles it. So once this works, then what we can do is we can just join it with the header. Yep, that's exactly what I wanted. Okay, so let's data is equal to let's prediction data probabilities, and then now what we do is we want to get rid of this and want to get rid of this. And the final piece is going to be string.join header. It's going to be string.join header. And then prediction probabilities. So we're going to have this, and then let's see. Write all tags, open right. Let's see, so now that we have the prediction probabilities, and that's gone, let's see, header. What I want to do is we'll take the header, but I do want to join this, so it's going to be string.join, comma, header, and join, and I want this to be inside of a thing here, right? And I want to add prediction probabilities, and this is going to tell me that it's a sequence string, string list, but here, so list.offseq, right? Let's data is equal to, and then now what I want to do is file.write all lines, and what I want to write, I want to write it to submission mission.csv, comma, what? Let me just make sure that this is a list of string content. It's going to be data. Okay. All right, let's try it. .NET build. .NET run. All right, So I'm hoping that this doesn't complain and that we're able to save our submission. And once we have our submission, then we can submit it to Kaggle. And today I've gone a little bit longer, but that's kind of because I want to finish and I want to get this up and submitted, which took way longer than I would have wanted to, but that's okay. Let's see here. Submission.csv. In the meantime, let me go here, cd test console, prediction console. The thing that we're going to want here is we're going to want to look at Kaggle and see how can you submit. Well, actually, I can, if I do this, right, I can just, my submissions, competition, see malware dash classification. So I can do that from within the API or the CLI, which is what we did before. Let's see. Still thinking. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, good. And you're still doing your thing. And this is looking through what, 10,000 rows? So it's gonna take a while for it to make predictions. Okay, let's see. So in the meantime, let's talk about project number 2, or the project that we're going to be working on next time. So it's very similar to this one, but at the same time, it's kind of different. And what I want to do is I want to use AutoML or the automated ML API to do a few things. What's it called? Kaggle malware. Let's just go with Kaggle malware. So there's the Kaggle malware prediction. That's what it is. And this should be fairly straightforward. So if we take a look at the data, right? So if we take a look at the data, it's just one file, actually two, sorry. There's two files, and you have a train and a test. So there's your test. What I like about this one is that this actually has the does it? Actually, I don't know if it does. Let's see, compact column. There's 82 columns here. How many columns are here? 83 columns. Okay, all right. So this one's the same thing, where you don't have a way to evaluate it locally. But anyway, as I was saying, this data set, it's pretty straightforward, right? What you're trying to predict is whether has detection. You're trying to predict this value here, has detections. It's the ground truth that indicates whether malware was detected on a machine, right? And it has all of these things, all of this data, right? But the only one that we care about, or we're going to use all of these as inputs to eventually predict, where is it? Has, where is it? Has, did I completely miss it? What is it? Has detection, right? Has detections. Is there like no, hold on. Let's see, train.csv. So there's columns. Let's look at the column names. It's previous beta, APX version, product name. I don't see. I don't see that column here. Maybe I'm missing it. Anyway, that's kind of what we're gonna want to do, right? And what I want to do is I don't want to. I'm gonna be lazy, and I don't want to try to find an algorithm for this. I want AutoML to do it for me. And my goal here in this case is what it's gonna be is, can I beat this score? So this is area under the curve, right? So can we beat the score from the top performers here using AutoML? Um, yeah. So I think that one should be fairly straightforward, right? We have all the data, and it should be just a matter of letting AutoML do its thing, and then we'll see how well it performs. Is this thing still going at it? Let's see. H top. All right. Both CPUs are going at it. Okay. Let's see. Wow, and my memory is just it's chugging along. All right. Let's see here. Mm-mm-mm. So let me see how I can better improve this thing in the meantime. How can we, let's see, by ref, in ref, which manage pointers. They have restrictions on use, so you cannot compile a program as valid and runtime. Okay, which is a structure that's similar semantics, compile time. Yeah, yeah, it is. It's really good resource utilization. So I'm not sure who's doing a good resource utilization there. I'm gonna say that ML.net is being smart about it and trying to use as much of my resources as possible. Because I know I certainly did not do best practices or try to what's it called? I did not try to like optimize or prematurely try to optimize my solution. I did what was quick, easy, and got the job done. But yeah, I don't know what exactly is taking up so many resources. There are 10,000 images that it's scoring, right? So there's quite a few images. Um, but I would think that the scoring piece would be a little bit, it would take a little bit less time. Um, but yeah, we'll see. Let's see. Have you folks worked with? So I'm trying to look. Um, I'm trying to take a Swagger file, right? So there's this thing that I'm kind of tinkering with, and what I want to do is I want to take a Swagger file inside of Visual Studio, and I want to create a client API, kind of like Swagger CodeGen. But I want to do that inside of Visual Studio to create a client for an API. I was looking at a few things. Um, so Visual Studio create REST API client. So there's some things that I was looking at that let me see. Web API client, add dependencies, making web request. No, and I'm trying to find like a sort of like an automated process to go about it, right? Like I want to kind of ah maybe. Hmm. But is this gonna, let's see, generative progress object model ICP, open API client provider. Yeah, Yeah, I think this might be it. Swagger provider, client dot get inventory async. I guess the question and swag tooling to create C sharp and C. Yeah, I guess the question here is so this Swagger provider will create the endpoints for me, but then I have to implement um like I'm trying to kind of understand like if a server. Yeah, like I'm just trying to think because I would think that like okay what the client will do is it's gonna try its best to allow me to interact with the endpoints, and because it's just like yeah, it's gonna automate a lot of stuff for me, right? So if it but at the same time I want to have some level of control over what my client does. I would like for it to kind of scaffold the endpoints, right? Like I wouldn't want to sit there and try to type out. So for example, in the pet store example, like I wouldn't have to create the entities and do all those things. Yeah, this doesn't look nice, but I wouldn't want to create the entities or the methods, right? But I like to have control over like how I generate um, like the logic that takes place with the data um, that's being sent back and forth between the client, right, and the server. But yeah, I mean, I'll give this a try because yeah, I mean, I don't really know without trying it, right, like whether it's gonna fit my needs. But thank you for sharing that. Um, yeah, it's just gonna be a matter of trying it and seeing what works. Is this one done? Not yet. Hmm. Okay, that's fine. Yeah, because there was this one. Let's see. If I can go back. Visual Studio. Let's see here. I think this is where it was. Create Restaurant and Swagger. I think this may have been one, or one of the ones. API client code generator. Yep. All right. Thanks. Thanks for stopping by. Yeah, this is the REST API client. And swag. ASP.NET Core. Let's see. Are we still? We're still going at it. All right. So it looks like we have like 5 minutes. I'll get off at 12. And this thing still seems to keep going. Um, if I'm not able to get this, let's see. If I give it just a little bit more time, I'll give it another 5 minutes, and then we'll see how we do. Um, all right. In the meantime, let's keep exploring NSwag. So close this. Go here to NSwag. Okay, NSwag, open specification, generate NSwag, C sharp, ASP.NET controllers. Getting started with NSwag and ASP.NET Core. can take advantage of this code generation by choosing one of the following options. Desktop app. Okay. Oh, cool. I like this. NSWAG Studio. And if I have an NSWAG file, and I want to create a C# client. Yeah. Cool. I think this might be kind of what I'm looking for. Base URL. Customize API documentation. Let's see here. We're still going. Oof. I did not expect for this to take so long. I wonder what the reason for that is. At the same time, I also can't close this down because if I do, then what that means is that I'll stop the process. Like if I kill this terminal, it'll stop the process. So I didn't think through this one. All right. No worries. We can keep learning here. Data annotations. Okay, so let's see. I don't know. Swagger. Popular Swagger. Popular Swagger. I don't know. Files. Sample Swagger files. Let's see. I'm just trying to find like some. It's OpenStack. Identity. Swagger file. WADL. No, that's not what I'm looking for. Let's see. Awesome Swagger. Curated list of awesome Swagger. Okay. Let's see. Swagger examples, projects, third party. Swagger.io, Swagger.repos. Yeah, it's not exactly what I was trying to find. Let's see here. Still going. I think what I might do is I might just stop this process and restart it inside of inside of this here in Tmux, and then that way I can leave it running and not have to worry about it. Yeah, let's do that. It's not cool, but first of all, let's start here by let's see here. Stamina, solution, program. Yep, this looks all right. Predict, added prediction project. Okay. And then what I want to do is I want to get rid of this here. And then inside of this. What I'll do is .NET run. And I'm going to hope that it does stuff. tmods.ls. All right, so let me quit this. All right, so thank you for joining me again for another session. It's unfortunate that we were not able to actually get the submission going here, but we're closer. We're closer. I was hoping that by today again we would be done with this. Not because I'm tired of it, but more because I kind of wanted to see the results of the work that we've been putting in for the past few months, or for the past month. That is. It feels like it's been a while, but it's only been about a month. And yeah, so in the next session, what we're going to do is we're going to try to hopefully by then our submission file has been generated. We can submit the submission and we can see how well we performed. So until then, until Monday, thanks a lot again for joining the stream, and I'll talk to you later next week. Take care. Bye.